Let's take a look at one of these graphing calculator problems. And for this particular problem, I have a particle that's moving along the s-axis, and we're given its velocity function given by this trig function right here, and our domain is from 0 to 2 pi. We're also given some information about the initial position of the particle, and the particle has a value of 2 when time t equals to 0. So this part right here, what that really means is that when time equals to 0, our position has a value of 2. So that is our initial position for this particular problem. And then we need to use your graphing calculator to evaluate the questions that are given to us. Okay, so for question number 1 here, I need to find at what times does the particle change directions. So since we're given the velocity function here, we can go ahead and graph that, and I've done that already. So here's my velocity function here, and what I'm going to do now is I'm going to go ahead and find the x-intercepts. So here's an x-intercept right here. So the time value here is pi over 2. And what that really means is that when you have an x-intercept, it really means your velocity function has a value of 0. So what that means is the particle is not moving. And then we just need to look at the signs on the left-hand side and the right-hand side of those particular time values. So one way that we could do that is we can draw a horizontal number line down here. I know that this will be 0, and this will be, the endpoint here will be 2 pi. And then I'm going to put the time values where the particle is not moving, which is pi over 2, and at 3 pi over 2. And I'm just going to look at the left and right hand side values when the particle is not moving. So on the left hand side of pi over 2, we're above the t-axis. So I can put these positive signs on my number line. And what that means is that the particle is moving away. And then on the right hand side of pi over 2, I'm below the t-axis. So I can put a minus sign in this interval right here. That indicates I'm below the t-axis. And when you're below the t-axis on a velocity time graph, it means the particle is actually coming back. And then on the right hand side of 3 pi over 2, we're above the t-axis, so I can put a plus sign here to indicate that. And when you're above the t-axis on a velocity time graph, it means you're going away. Okay, so if I take a look at this number line, clearly at pi over 2, the signs change from positive to negative, so that means it's changing directions. So once again, if you have these positive signs, it means the particle is going away, and if you have these negative signs, it means the particle is coming back. So since the signs change, it means that at pi over 2, the particle is changing direction. And by the same argument, at 3 pi over 2, the particle is also changing directions because the signs change from negative to positive, right? So when you're below the t-axis, it means you're coming back. And when you have a positive sign, it means you're going away. So that's the sign change. Okay, let's move on to question number 2 now. And for question number 2, I need to find the position of the particle at time t equals to 3. So basically, you need to find the final position after 3 seconds. And we do have a formula for that. And that is your final position is equal to your initial position plus your displacement, which is from A to B of your velocity function dt. So this is a little formula that was given to you in your class notes, and this will help you find the final position of your particle. And we want to find our final position after 3 seconds. And our starting time for this problem is going to be 0 seconds. And basically, we're just plugging in the numbers into the formula as well as the function. So our velocity function is given to us at the start of the problem, and that's going to be 3e to the cos t minus 3, and then I'll put this in brackets here, and then this is with respect to t here, so dt. Okay, and then from there, let's do one more thing here. This part right here, s is 0, that was given to us at the start of the problem, and I did highlight that at the very beginning here, so s is 0 has a value of 2. All right, so it comes into play for question number 2 now. So s is 0 equals to 2, so this part has a value of positive 2. And then for the rest of this problem, if you put let me get a purple marker here. If you put this expression into a graphing calculator, you will get a value of 2.776 roughly, and then your final answer will be 4.776. Okay, so there's the answer right there. And if you are on Desmos, this is another way where you can just input this information to Desmos, and this is another way where you can just get the answer, 4.776. So define f of x as your velocity function, and then just use your final position formula there. So this right here is really s is 0, right? And this right here is your displacement. Okay, that's it for that particular question. Let's move on to question number 3. And for question number 3, I need to find the displacement of the particle from time t equals to 0 to time t equals to pi. So when you're given these time values, this is really your a value and this is your b value for your formula. And if you're looking for displacement, displacement has the symbol d with the hat on top. And the formula for displacement is the integral from a to b of v of t dt. And then all you're doing now is you're plugging numbers into this formula here. So this is the integral. This is going from 0 to pi. And I'll use a green marker again. My velocity function is 3e to the power of cos t minus 3. And I'll put that in brackets, dt, right? And then from there, you can go to a calculator, and from a calculator, you should get roughly 2.508. Okay, let's move on. And if you're on Desmos, once again, you can define your velocity function as f of x, and then you can just put this integral expression into Desmos, and there you go. There's your answer, and you can just round that to 3 decimal places. Okay, let's move on to question number 4. So question number 4, now I need to find the total distance traveled by the particle from time t equals to 0 to time t equals to pi. So this is your a value, this is your b value. Now total distance, I'll just say TD for total distance. That also has a formula for our class, and that's the integral from a to b. And this time you're taking the absolute value of your velocity time function. And then with respect to time. Okay, so it's very similar to your displacement formula. You're just putting absolute values around your velocity function. And if we're going to input the numbers into this new formula here, this is going from 0 to pi. And then you have your absolute value function, and your velocity function is 3e to the cos t minus 3. And then I'll close that off. And then we're integrating with respect to t, so I need a dt here. Okay, so you would plug that into your formula, and you would get 6.694. Okay, and there you go. This is how you would put this into Desmos here. So here's your velocity function there, and here's how you would put your absolute value function in there. Just say ABS, and just round that to 3 decimal places. Okay, let's keep on going along. Question number 5. This time I'm going to find the average velocity of the particle over this given interval. So our A value is going to be 1, and our B value is going to be 4. Okay, so if I want to find average velocity now, I can say velocity and then average, AVG. And we do have a formula for that as well. That's 1 over B minus A times the integral from A to B. And this is your velocity function there with respect to t there. So there's our average velocity formula there. And now let's just input the numbers here. So 1 divided by, the b value is 4, the a value is 1, times the integral from 1 to 4. And then I'll use my green marker again. Our velocity function is 3e to the cos t minus 3. And this is with respect to t, so I need a dt there. And once again, you would just go to a calculator in this case, and I get negative 1.007. Okay, and then if you're a Desmos user here, I would just define your velocity function as f of x again, like all the previous calculations, and you can just put that right into your input that right into Desmos, and you can round that to 3 decimal places. Okay, let's keep on moving along. For question number 6, I want to find the average acceleration, and our A value is 1, our B value is 4, and for average acceleration here, the keyword is average, so this is the average rate of change. So if I want to find the average acceleration, this is the same thing as the slope of the secant line, so this will be V of B minus V of A divided by B minus A. Alright, so that is the slope of the secant line there. And let's go ahead and just plug in the numbers here. So this will be V of 4 minus V of 1 all over 4 minus 1. And just make a note that your velocity function is given to you at the start of this problem, which is 3 e to the cos t minus 3, right? So we're plugging in, whenever you have a t there, we got to change those values to 4 and 1 to calculate the numerator there, right? Now, if you're on your graphing calculator or on Desmos, those kind of calculators can do these calculations very quickly here. And anyways, if you do go to your calculator, you should get about negative 1.196. And I'll show you a little screenshot on what you can do on Desmos here. So this is what I would do on Desmos. I would define your velocity function as f of x, and then I would just type in this expression like that, and there's your answer right there to 3 decimal places. Okay, let's move on to the last question here. The last question here is find the time t at which the particle is farthest to the right. Show an analysis to support your answer there. Okay, so what we need to do is I've actually found certain these time values right here. And these 4 time values, you basically want to find out where your particle is at those time values. So we want to find out where your particle is at the beginning at time t equals to 0. And remember, this is your velocity function. So if we're looking for the situation where you're farthest to the right, we need to find our position at those particular times. And then at pi over 2, I mean, you're going away. And then from pi over 2 to 3 pi over 2, you're coming back. And then finally, at the very end, you stop at 2 pi, right? So we just want to find out what our position is at those particular cases. So I want to find out where's my position at s of 0. I also want to find out where my position of my particle is at pi over 2. And I also want to find out where is the particle at 3 pi over 2. And I also want to find out where's the particle at 2 pi. Okay, so that's basically what we're trying to do in this particular problem. And for this particular problem, what we're going to use is the final position formula here. But before I use that particular formula, I just want to say that you do know what s of 0 is. This is given to you at the start of the problem. That's going to have a value of 2. Okay, and if you want to go ahead and find the position at these particular time values, you need to go back and use your final position formula, which is s of b equals to s of a plus the integral from a to b of your displacement, which is v of t dt, right? So this part right here is your displacement, right? But you're using this particular formula right now to find the position of the particle in those next 3 cases here. So if I had to just translate for this one, this would be s of pi over 2 equals to s of 0 plus the integral from 0 to pi over 2 of your velocity function dt. All right, so you'd find out where the position of that particle would be, and you do the same thing at 3 pi over 2. So if I had to just kind of write this all out here, and don't worry, we'll just jump to the calculator to figure this out, but we want to find the final position of the particle at these particular times, and this is how you would input the numbers into your final position formula here. And finally, we have s of 2 pi, which is your initial position, plus the displacement from 0 to 2 pi of your velocity function there. Okay, so that's the general idea of this particular problem. And what I'm going to do next is I'm just going to go to Desmos here and show you how you can just calculate all that very quickly. So this is the position at pi over 2. And at 3 pi over 2, your position is that. And at 2 pi, your position is that. So this is how you can easily use Desmos to find the final position. And once again, just define your velocity function as f of x right there. And then we also know that this 2 right here, this is really your initial position, right? So anytime you have a value of 2 here, that's really your initial position. Okay, so let's go ahead and see if we can kind of just explain the results here. I can tell you that since we have the highest value here is 7.015, I would say at a time value 2 pi, the particle is farthest to the right. But let's go ahead and just kind of translate all of this so that it makes sense on a number line here. So if I have to draw a little number line here, I'll just draw a number line like that. And I'll just say that right here, this has to do with your position time value. So what I'm just trying to say is that when time t equals to 0, actually let me go a little bit further down here, when time t equals to 0, you're at a position of 2. Okay? And then what's happening now is at pi over 2, that's going to be as a time value a bit later on in the problem here, but at time t equals to pi over 2, the particle is moving away, and it's now in a position of 6.6007. Okay, so the particle started here, has initial value of 2, and after pi over 2 seconds, it's moving away, and then it has a position at 6.6007. Okay, and then our next time value is 3 pi over 2, and you might remember from the very first question of this particular problem, at 3 pi over 2, we're actually coming back, right? So it has a value of 2.4144. So what that means is, let me just kind of say that this value is maybe a 2.4144. What's happening is the particle is actually turning back now, and it's going backwards now, or coming back home. And this is a time value of 3 pi over 2. So at 3 pi over 2 is at a position of 2.4144. So it actually is actually coming back. And then finally, we have a time value of we have a time value of 2 pi, and it finishes its position at 7.015. So let me kind of put that time value a little bit further out here. So over here now, the final position is at 7.015. And now the particle is now going away again. And it's going over here now. So this is the time value right here at 2 pi. So at 2 pi, the position the particle is at 7.015, which is furthest to the right. Okay, so if you compare that to these other green values here, the number that's furthest to the right is actually this number right here, which is 7.015, and that happens after the particle has traveled for 2 pi seconds. Okay, so there's your answer for that particular case. And if I just go back to the original question now, you can see when is it furthest to the right, and that's at 2 pi. So we're given the velocity time graph right here. Remember, this question gives you information about the velocity of the function, and through analysis here, then we can create a horizontal number line to kind of graph the position of the particle, and this is what's happening. And once again, from at the start of the problem, we are going away, and then we're coming back, and then we're going away again. All right, so that kind of correlates to the first part of the question as well there. And that's how you would graph this question on a horizontal number line. Okay, that's it for this homework video guide.